Hey there, science fans! Today, we're diving into the fascinating world of data chips, the tiny giants powering our modern lives. You know, those little things that make our smartphones smart, our cars drive themselves, and even send rockets into space. From the moment you wake up to the time you hit the hay, you're interacting with devices that rely on data chips. They're in your alarm clock, your coffee maker, and even your toothbrush. Yes, really. These tiny wonders are the brains behind countless gadgets and systems, making our lives easier, more connected, and way more fun. But have you ever stopped to think about what data chips actually are and how they work? It's pretty amazing when you break it down. So, let's grab our magnifying glasses and explore the incredible world of data chips. Get ready for a wild ride through the world of transistors, binary code, and the amazing science behind these technological marvels. Stay tuned. Alright, let's get down to basics. What exactly are data chips? In simple terms, they're like tiny electronic brains that control the flow of information in electronic devices. They're made up of billions, even trillions of microscopic components etched onto a small piece of semiconductor material, usually silicon. Think of a data chip like a bustling city. Just like a city has roads, buildings, and traffic lights, a chip has circuits, transistors, and other components that work together to process and store information. This information is what makes your phone take pictures, your computer play games, and your GPS navigate you home. Data chips come in all shapes and sizes, from the tiny ones in your headphones to the powerful ones in supercomputers, but no matter their size, they all share the same basic function, processing information with incredible speed and precision. Next up, we'll unravel the mystery of how these tiny brains actually work. Stay tuned. Okay, science fans, time to get a little more technical. At the heart of every data chip are transistors, microscopic switches that control the flow of electricity. Think of a transistor like a light switch. It can be either on or off, allowing or blocking the flow of current. Now here's where it gets really cool. Computers use a language called binary code, which is made up of just two digits, 0 and 1. Each digit in binary code represents a different state of a transistor. 0 means off, and 1 means on. By combining these on and off states in different ways, we can represent all sorts of information, from numbers and letters to images and sounds. Imagine a group of friends using flashlights to communicate in the dark. If they agree that one flash means yes and two flashes mean no, they can send each other simple messages. That's kind of how binary code works, except instead of flashes of light, it uses the on and off states of billions of transistors to process and store information. It's mind-boggling to think that all the complex tasks our devices perform, from streaming movies to playing video games, boil down to these simple on and off switches. But that's the beauty of binary code. It's a simple system that can be used to represent an incredible amount of information. Next, we'll take a peek inside a chip factory and see how these technological marvels are made. Don't touch that dial. Hold on to your hats, science enthusiasts, because we're about to enter the clean rooms of chip fabrication plants, where the magic happens. Creating data chips is a complex and fascinating process, involving hundreds of steps and requiring incredible precision. It all starts with a silicon wafer, a thin, circular slice of extremely pure silicon. Think of it like a giant pizza for tiny transistors. This wafer goes through a series of processes like photolithography, etching, and doping to create the intricate layers of transistors, circuits, and connections that make up a chip. Imagine using stencils and special light to draw incredibly small patterns on the wafer, then using chemicals to etch those patterns onto the silicon. It's like creating a super detailed, microscopic work of art, layer by layer. Once the chip structure is complete, it's cut into individual chips, packaged and tested rigorously to ensure they meet the highest standards of performance and reliability. The manufacturing process is a true testament to human ingenuity and our ability to manipulate materials at the atomic level. It's a global effort, with companies around the world specializing in different aspects of chip production. Speaking of global efforts, let's meet some of the major players in the chip-making game in our next segment. Section 5. The Chip Champions, major players in the industry. The world of data chip manufacturing is a competitive one, with companies vying for dominance in this high-stakes industry. Think of it like a relay race, with each company passing the baton of innovation to the next. Some of the biggest names in the game include Intel, Samsung, and TSMC, or Taiwan Semiconductor Manufacturing Company. These companies invest billions of dollars in research and development, constantly pushing the boundaries of what's possible with data chips. Intel, based in the United States, is known for its powerful computer processors. Samsung, a South Korean tech giant, is a major player in both memory chips and processors. TSMC, based in Taiwan, is the world's largest dedicated semiconductor foundry, meaning they manufacture chips designed by other companies. The competition between these chip giants is fierce, but it's ultimately a good thing for consumers like us. It drives innovation, lowers prices, and leads to more powerful and efficient devices. But even with all this progress, the data chip industry faces some significant challenges, which we'll explore in the next section. Stay tuned. Section 6. Challenges on the horizon. Size, heat, and Moore's Law. As we demand more and more from our devices, chip makers face the daunting task of cramming ever-increasing numbers of transistors onto chips that are already incredibly small. It's like trying to fit an entire library into a shoebox. This miniaturization trend is famously described by Moore's Law, which states that the number of transistors on a chip doubles roughly every 2 years. While this law has held true for decades, it's starting to bump up against the laws of physics. As transistors get smaller, they generate more heat, making it harder to keep chips cool and functioning properly. Imagine trying to run a marathon in a sauna. It's not going to be pretty. Heat dissipation is a major challenge for chip designers, who are constantly searching for new ways to keep their creations from overheating. But fear not, science fans. The world of technology is full of brilliant minds working on innovative solutions to these challenges. In our next section, we'll explore some of the exciting advancements on the horizon. Section 7. The future is now. AI chips, quantum computing, and beyond. The future of data chips is brimming with possibilities. Researchers are constantly pushing the boundaries of what's possible, exploring new materials, architectures, and computing paradigms. It's like a science fiction movie come to life. One exciting area of development is AI chips, specifically designed for artificial intelligence applications. These chips are optimized for the unique demands of machine learning algorithms, enabling faster and more efficient AI processing. Think self-driving cars that can make split-second decisions, or robots that can learn and adapt to new environments. Another game-changing technology is quantum computing, which harnesses the bizarre laws of quantum mechanics to perform calculations at speeds unimaginable with traditional computers. While still in its early stages, quantum computing has the potential to revolutionize fields like medicine, materials science, and artificial intelligence. The future of data chips is full of unknowns, but one thing is certain: these tiny giants will continue to play a pivotal role in shaping our world for generations to come. So buckle up, science enthusiasts, because the ride is just getting started. Section 8. Conclusion: Data chips, the heart of innovation. From the smartphones in our pockets to the spacecraft exploring the cosmos, data chips are the unseen heroes powering our technological world. These tiny marvels of engineering have revolutionized the way we live, work, and interact with the world around us. We've journeyed from the basic building blocks of transistors and binary code to the complex manufacturing processes that bring these chips to life. We've met the industry giants driving innovation and explored the challenges and opportunities that lie ahead. As we stand on the cusp of a new era of technological advancement, one thing is clear: data chips will continue to be at the heart of innovation, enabling us to solve some of the world's most pressing problems and unlock a future brimming with possibilities. So the next time you use your smartphone, fire up your computer, or marvel at the latest technological wonder, take a moment to appreciate the tiny giants working tirelessly behind the scenes, making it all possible. Keep asking questions, keep exploring, and never stop learning, because the world of science and technology is full of endless wonder.